Hey, welcome back to Workplace 30. We are continuing on with section 4.2, which is part of the probability chapter. So we're going to start by reading page 160, discuss the ideas, and its probability in a traditional Dene game. Go ahead and you can read that now. Question 1. Assuming that the captain correctly picks the opposing team member who is holding the token, what is the probability of the captain choosing the correct hand? So assuming they have already chosen the correct person, so they know that it's this one person, and then that one person has two possible hands that it could be in. So your probability is going to be 1, because the coin is in one out of the two hands. So your probability is 1/2. Number 2, in the first round, what is the probability that the captain will choose the hand of the opposing team member who is holding the token? So how many people total are playing? Okay, there's 4 people playing. Each person has 2 hands. So we know that the total options where the coin could be is 8. And we know that there's only one coin, so there's one coin in one of those 8 hands. So our probability is 1/8. 3. If the captain gets his first choice wrong, does that affect the probability that his second choice will be correct? In other words, is the probability of the second choice dependent on the results of the first? Explain your answer. So actually, it was kind of hard to figure this out when reading the passage, but it seemed like after he would make a choice or an incorrect choice, they would all put their hands back under the blanket and then change where the coin was located. So since that's the case, actually, there would be no effect on the probability of guessing the second time because the first time it was moved. So your first guess was really irrelevant. So, is it dependent? No, it's not dependent on the first time. Number 4. In the first round, the captain eliminates one player. In the second round, when only 3 opposing team members remain, what is the probability that the captain will choose the hand of a remaining opposing team member who is holding the token? So there's 3 people left. Each of those people has 2 hands. So that means our total options where the coin could be are 6, because there's 6 different hands the coins could be hiding in. Again, we only have one coin, so our probability would be 1/6. Then we're going to go to mental math and estimation. We have a grocery store is doing a promotion to increase sales. Every customer who enters the store receives a scratch card. The card will be scratched when the customer makes a purchase, and the customer will receive the discount shown on the card. The store has printed a total of 5,000 scratch cards with the following values. How many cards were printed that offer a 25% discount? What is the probability of receiving a card with a 25% discount? So we need to figure out how many cards give 25% off. Now the key to this question is that this number of cards has to total 5,000 because every card does have some kind of discount. So we're going to go 5,000 minus 3,000 minus 1973 minus 2 to get a total of 25 cards have 25% off. So now we need to figure out this probability. So there's 25 out of 5,000, so P equals 25 out of 5,000 cards, which we can reduce to 1 out of 200 chance of getting one of those cards that is 25% off. So that's your probability. Then we're going to look at the roots of math, weather balloons, and prediction. So go ahead and read page 165. Now question number 1 says, if in 1 year 2,432 radiosondes were sent up and 810 were found, how many radiosondes would you expect to be found the next year if 2,639 were sent up? So in this case, there's 2 different options. First, you could figure out the probability. So you could say P equals 810 out of 2,432 to get approximately 0.33 as a probability. Then you could take the amount sent up next year, 2,639, and multiply it by your probability to get approximately 879 would be sent up. Now, that way is good. Another way that I also like just minimize that, is cross multiplying. Now I know you all know how to cross multiply. So if you go 810 over 2,432, set it equal to x, because x is what you're looking for, over 2,639, cross multiply, you'll find that x equals approximately 879 also. So either way will work, whichever you're more comfortable with. Now 2, what is the probability that a radiosonde sent into the atmosphere will not be found? So now we need to figure out the amount that won't be found. To do this, we need to find the number not found the first time. So out of a total of 2,432, 810 were found, so we'll subtract that from our original number to get a total of 1,622 were not found. So if those were not found, we now need to figure out that probability. So probability is 1,622 that were not found out of a total of 2,432, which is approximately 0.67, or a 67% chance that they will not be found. Now something interesting, sometimes they would send up non-human passengers on these test runs. What is one example of a non-human passenger that you think they sent up? It was actually a duck. They would sometimes send ducks along with other small animals on these test runs. You now have an assignment, page 163, number 6 to 8. And if you have lots of time left in your class, please try number 9 also. It's a good question and something that you might see on an exam.